Hey guys, hope you're doing well. Thanks for watching today's video where we're going to go through some practice problems using all the formulas that we talked about in the last video. So I know they probably seem really confusing right now, but once you start applying them, you're really going to realize that these aren't too bad. So again, let's quickly go through each one. The first is the intersecting chords formula. So this is when we have two chords. We say that the parts of each chord can be multiplied together to equal the parts of another chord. So the chord with parts A and B, you can multiply those two and you can then get the parts C and D. So if you have 3 of the 4, it's pretty easy to find the last one. Then we have the secant formula. So this is, remember, a secant is a line that goes through the circle at 2 points. So a chord ends at the edges of the circle. A secant can keep going. And if you have two secants joined by an external point, that's this right here, that point that they meet at, then you take the length of the entire secant and you multiply it by its external part, and that will equal the same thing on the other secant. So the length of the entire secant is A here. I'm going to multiply it by that external part B. That needs to equal the length of the entire secant C multiplied by its external part D. So again, we'll go through some practice in a second. Then the secant tangent formula, really closely related to the secant formula, except now we're again going to take the length of the entire external part, multiply it, the entire secant, I should say, the B part, and multiply by its external part C. Then we're going to equal that to the tangent part, that's this part right here, joined at that external point to that point on the circle, and we're just going to square it. So it's basically A times A equals B times C. So again, not too difficult, but we just need to practice with it to where it starts to make sense. So, example 1. So they give us this, and we need to figure out what x equals. The first thing you need to do when you get problems like this is identify, well, which rule am I working with? Do I have a chord intersecting chords problem? Do I have a secant tangent problem? Or do I have a secant problem? So let's identify that first. I see that this is a line that goes through a chord. There's a chord right here, but it keeps going. So that's a secant. So this first line is a secant, so I know that. So I'm either going to have a secant tangent or a secant. And the thing is, this line also goes right through. It doesn't just intersect at one point, because that would be a tangent, but it keeps going through, so that's going to be a secant. So now I need to remember that rule. Well, I remember that it said the length of the entire secant, so this whole measurement, times the length of its external part. So, well, the length of the entire secant is going to be 18, 10 plus 8. So I'm going to take 18 times, well, then it says I multiply by the length of its external part. Well, that's going to be 8, because that's the part outside of the circle, but still part of the secant. So 18 times 8 equals, now I have to do the length of the entire secant here, which I've labeled as x, so I'm going to say x times the length of its external part, which is this 9 here. So now I'm going to simplify. Got to do 18 times 8. Let me get my calculator out here. 1 second. Got to find it. All right, 18 times 8. I get 144. So 144 equals, and I'm going to rewrite this as 9x instead of x9. Makes it a little simpler. Divide both sides by 9, obviously. And we get x equals 144 divided by 9, which is 16. So x is 16. So that is the length of the entire secant. So remember our process here. First step was to identify that it was a secant, and then you just go through the rules. So it's not hard problems. The hardest part is really just memorizing the rules. So let's look at the next one. All right, so this one seems pretty obvious to me because only one situation has this tangent. This is obviously a tangent because it only touches the circle at one point, right there. So that's a tangent. If I know that, and then I can quickly see that the other one is a secant, so tangent secant formula. And I remember that this one is very closely related to the secant formula, where I do need to take, for the secant, I need to take the full part, which is going to be 28. That's the length of the entire secant. Then I multiply it again by its external part, and that's going to be this 10 right here. So I take the length of the entire secant, which is 28, multiply it by the length of its external part, which we said was 10. And that equals, now we need to remember, well, what does that equal? Well, that equals this tangent part squared. So just x squared. and that's it. So this is just solving a basic algebra problem basically. So 28 times 10 is 280 equals x squared. And then what do we do here? Well, we take the square root of both sides. So x equals the square root of 280. And just for practice, let's simplify that. So remember, we take factor trees to simplify our square roots. So what can go into 280? Well, let's do the easiest one, which is 240. What can go into 140? Easiest one again, 2 and 70. What can go into 70? Well, 35 and 2. What can go into 35? 7 and 5. And I think that's it. So now what you can do once you have this factor tree is you circle the two numbers. If they match, you can take one out. So if I have two 2's, that's like this 4 being inside. So the square root of 4 is 2, so I can take a 2 out. So I'm left with 2 times the square root. And I don't have 2 of anything else. See, I have this 2, I have a 5, and I have a 7. So all of them are going to stay inside the square root. So 2 times 7 times 5. Then I get 2 times the square root. Now I'm just going to do 2 times 7 times 5. I'm going to start with 2 times 5 because that's 10. Multiply that by 7, I get 70. So 2 square root of 70 is the simplified way to write square root of 280, because most teachers like you to simplify before on a test, and it's just good practice to simplify in general. So that's how you do that. So our answer would be 2 square root of 70. So again, the hardest part is really just setting up the problem, and you just have to know the rules. If you know the rules, you're good. So last example, you can probably guess what one we're going to have here. So obviously this one is pretty easy to spot because we don't have a secant, and the only one that doesn't have a secant, well, that is the intersecting chords formula, which says that if I multiply the parts of one chord, they're equal to multiplying the parts of another chord. So as you can see, my first chord is going to be this chord that has the 6 and the 12. Sorry, my lines are clearly not drawn to scale, but so 6 times 12, the parts of that first chord equals the parts of the second chord multiplied together, which is 4 times x. So 6 times 12 is 72, which equals 4x. Divide both sides by 4. 72 divided by 4, that should be 18, I believe. So x equals 18. And that would be the length of that part of the chord. So that's all we have today. I hope this was able to make sense. I hope this clears up the confusion that you probably had after watching our last video where we just kind of introduced the formulas. This can definitely be a hard topic for a lot of students. So practice these, and practice these. Really just know the formulas. I recommend writing them down and just studying them kind of like flashcards. The secant, the secant tangent, and the intersecting chords. Those are the 3 you have to know. And practice is the only way to really get better at them. So thanks for watching. Hope this was able to help. Let me know if you have any questions.